So in this lecture, in this part, I will talk about system building and release pipelines. Okay. So first, let's look at what is a software release. So first, so during development process, so you may want to add a new feature, right? Add a new feature, and then you want to fix some bugs maybe introduced when you added the new feature. And then you may be needing to refactor your code because you made your code changes in a rush, so you didn't had a chance to make a clean code. So you refactor your code. Then you deliver everything to the customer, or you deliver a service to your users. So this is a release, okay? Let's do an imagination, right? Imagine that yesterday your boss asked you to demonstrate the great new features of your system to a customer, but you cannot show them anything. You have a critical bug in production and you know how to fix, but your time to release is 1 week. So you cannot do this demonstration. But actually fixing the bug will be very quick, but it takes a week to release it to the environment, okay? Are these problems common? If it's yes, so maybe there may be something wrong. So releasing a software using 1 week is not an inevitable outcome of software releasing, okay? So also think about how long would it take for your organization to deploy a change that involves just one single line of code. If it takes several days, there may be problems, right? Also think about what is our cycle time from deciding what you need to make a change to having it in production. If it takes too long, there may be problems. Traditionally, so how people do releasing, right? So people release software manually. So they take this code and they build it and they transfer it to the deployment environment or transfer it to customers manually. It's a slow process. They only release the software when the development is complete, okay? And they also do manual configuration of the product environments. That's the reason why releasing the code changes takes 1 week or longer, right? So can we do better? As we know, so the modern software systems are usually released very fast. For example, so these systems, they are usually released several times in 1 day, right? So how can we handle this fast release cycle? So we need to release pipelines. These pipelines will automate our release process and to make it faster and reduce our manual effort. So how organizations deliver new content? For example, so when we have a code change, when we have a patch, we do integration. We integrate this code change into our repository, such as Git repository. Then we will do a build. We build this repository, build the code into a package or a program. Finally, so we would release or deploy our package or program into the production environment. That is a release pipeline, integration, build, and deployment. And modern software systems actually would rely on efficient and robust release pipelines, okay? So we need experts to develop, maintain, and operate them. We do experts for the whole release pipeline. Okay. So this is a release engineer. So what are the challenges for a release pipeline? As we already discussed, we have integration, build, and deployment. So let's first look at a build, right? So what is build, right? A build system. What's a build system? So first, we have our source code, which are like components, individual components are vehicle. We have our source code. So we want to integrate our source code together into one package or one component. Like we assemble all the components into a vehicle. That's what the job of a build system is. Okay, it's a build system. So how it works, right? So actually, the build system will describe how sources are translated into deliverables. For example, we have source code Java or other files like .text. Then we would compile them and link them together into a package. Let's look at details. First, we have the source code. For example, we have a random number generator source code. We have another source code file for user input handling. We have a main file. Then we compile each of them individually, right? Then we link the compile output together into a program. This is the whole build process. Okay. Sometimes maybe we find there's a bug, right? So we for example, there may be a bug in a random number generation component. So we want to fix the bug. So we need to recompile it. And we need to relink everything, right? So to generate an updated program. So, but there's a problem, right? What files did I just change? Which commands do I need to run again? So if you want to manually repeat this process, it may be very slow and you may lose your track, right? So luckily, so we have a build systems that can help us make our decisions. So we have automated build systems that can save our manual effort to do the complex build things. So there are different automated build systems or build tools. So what do they do, right? The build tools automated the tasks such as compiling the code, such as performing static analysis, running the tests, doing the dependency management, do the packaging, doing the deploying. Everything can be automated. So some examples, for example, we have make for C or C++, and Maven and Gradle for Java. We have a Rug for Ruby. We have NPM for Node.js. So those are automated build tools, right? For example, so we can use Gradle to create a Java project from scratch automatically, very fast, and to automate the build process. For example, first step, we just install Gradle. We make a folder, a project folder. We init the project. We set up to Eclipse how to use the Eclipse plugin, right? Then we run a test. That's it. That's a whole process that you where you create a project, you just deploy the build, how to build the build pipeline, okay? So there's one thing to consider, that building a system is not just building the code. It involves building everything within the system. For example, we have source code files, we have data files, we have libraries, we have configuration files, we have documentation, we may have other dependencies, test files, for example. We want to build everything together into one package. Okay, that is system building. So we just mentioned So modern software systems are released very fast, for example, several times a day, right? So we need to integrate new changes more frequently to keep up with fast-paced development. So how we can do it, we'll discuss. We can do continuous integration, right? So what is continuous integration? Let's just review it quickly. First, we make code changes, right? So we commit the code change to our repository. Then we build our system, and we test our system, and test passed. So we commit. The commit was accepted. So that is a continuous integration process. So the whole process can be automated by the tool, automated tools. Okay. So in addition to continuous integration, we have continuous deployment. So basically, we want to deploy our product into the product environment. What continuous delivery? So we want to deliver our software product to our customers automatically. Okay. So what is a continuous deployment, right? So let's just have a look at one example. So we want to deploy our software product into the production environment. So what is our production environment? It can be, for example, typically can be your actual product environment in a cloud, or your customer product environment, or you want to deploy into a Docker Hub, right? So you want to create a Docker image and to deploy to Docker Hub. So let's look at the example of a Docker Hub, right? So first, you push everything to Git, to your repository, and the continuous integration or continuous deployment tool. For example, here we'll have a Jenkins would be triggered, right? So Jenkins is triggered. The Jenkins actually receives the notification. They would clone this workspace, right? And they would run tests. They would even run other checks like static analysis checks. And then they would create an image, a Docker image, and then they would run some other tests, like a system test. Then finally, they would push that image to Docker Hub. This is how it works. For example, for sure, they need to clone the code from the Git server, because after they receive the notification, they would clone the code from Git before they run a building, run a testing, run a static analysis, right? So this is a typical deployment pipeline. So there are article and source code, so you may check. Okay. So this is how we release a software to a production environment. But let's imagine how we can safely deploy our releases to a large number of users. For example, Amazon, Facebook, Google, they have millions to even billions of users in the world. So how can they, after they make changes, how can they safely deploy the changes to the customers, right? If we just deploy everything to our customers in one batch, that might be very dangerous, right? And there may be some problems that you haven't discovered in your testing, and you deliver to like everyone of you or of our users, of your users. That's very dangerous. So in order to reduce the risk, so there are different releasing strategies. First one, there's some examples. The first one is called blue-green deployments, right? The second one is called canary releasing. So we'll talk about each of them separately. What is a blue-green deployment? So this deployment reduces the downtime risk by running two identical production environments called blue and green. Instead of running one production environment, we run two, right? So first we have a green one, and also have a blue one, or two production environment. And in one production environment, we run the old version. In another environment, we run a new version, right? First, other users are direct to the old version, right? Then after we have a new version, so we try to direct other users to the new version. And if there is any problem in the field, in the production environment, so we would redirect other users to the previous version to reduce the risk. This is a blue-green deployment. Okay, so this can reduce the risk by having two versions of the system. So whenever one version has a problem, we direct the users to another version. Okay, so what is a calorie releasing? Calorie releasing is basically similar, but even better, right? So it reduces the risk of introducing a new software version in production by slowly rolling out the change to a small subset of users before rolling it out to the entire infrastructure and making it available to everybody. So it's a gradual rolling out. We also have two versions here, old version and new version. At the beginning, we deploy the new version of our software to a subset of our infrastructure. So for example, to a subset of our servers, right? To a 5% of the servers, for example. But no user are directed to these new versions. And then after we do some testing in the production environment, and we redirect a small subset of the users, for example, 5% of the users into a new version, new infrastructure, right? It's the second step. Then we get, based on the evaluation on the 5%, right? So we get more confidence in the new version. So we start releasing to more servers, and also redirect more users into the new version. We do this gradually until all the users have been routed to the new version, right? So after that, we can decommission the old infrastructure. So we only keep the new version. That's a gradual rolling out. It's called calorie releasing. Okay. Okay, that's about building and release pipeline, right? And also we talk about the releasing strategies. So to summary, we have introduced different terms in this lecture. So I want to remember these terms, right? So like baseline, what is baseline? What is branching? What is merging? What is code line? What is version control, configuration control? What is configuration item or configuration? Software configuration item. So software configuration item is for example, is a one code file, one document, or one of other artifacts that you have versioning on it. That's a configuration item. I have a main line. What's a main line, right? Merging, release, repository, system building, version, workspace. We have discussed all of these concepts. Okay. So there's an exercise. So basically, we already introduced this exercise briefly. So in this exercise, so I want you to practice continuous deployment. I want you to build in the previous one, you practice a continuous integration. This time, I want you to practice a continuous deployment. Basically, I want you to build a deployment pipeline and continuous deploy an open source application to Docker Hub. Right, you deploy your system to Docker Hub continuously. So there's a tutorial, and also there's a code that you can use, and you can follow this article and to reuse this code. So this article, they use Jenkins tool. You can use Travis CI, and there's a documentation for Travis CI about how to deploy open source application or any application to Docker Hub. Okay. So that's it for this week. And yeah, that's it for this lecture. Thank you, everyone. Do we have any questions?
Not in the chat.
Okay. Thank you, everyone, and we should have a great week ahead. Okay. Thanks. Bye-bye.